How are y'all doing today? My PowerPoint will be on water heater safety devices. So a little background on water heaters themselves. So the first designed water heater that was automatic and storage tank type was created by Edwin Rudd, who was a Norwegian mechanical engineer that was working in Philadelphia. He made the first design around 1889 and didn't get a patent until around 1897. So a few decades after that, he was just iterating the design and making it better and better. But in around 1920, only 1% of the U.S. had working electricity and plumbing. So, it didn't really take off until around the 1940s is when the water heaters became a household item. Here are the three main types of water heaters. The first one being electric and gas. These are the most common water heaters. In the third one, the picture to the right, you'll see the steam-powered water heater. All these water heaters need safety devices in case of high pressure, high temperature scenarios that can cause damage or anything like that. And some of the safety devices that you'll see in this presentation include temperature and pressure safety relief valves, drain lines and pipes, draft hoods, thermal switches, expansion tanks, gas drain thermocouples, and a few other things. The first safety device that we will be looking at is a temperature and pressure relief valve, also known as a TMP valve. These are used in almost every electric and gas-powered water heater. The main function of this device is to relieve excessively high pressure and temperature in these water heaters. So some thermal expansion usually occurs in the tank, but too much can cause a lot of issues and safety concerns. And around 120, 140 degrees Fahrenheit is when the tank actually starts to expand, but it's not until around 200 degrees Fahrenheit and pressure of 150 pounds per square inch that the standard TMP valve will actually release and discharge water down the side of the water heater. In the next slide, I will show a schematic of how this works and the inner workings of this TMP valve. Here's a schematic of the temperature and pressure valve. So first off, you see the control handle at the very top. This is used to manually loosen or tighten the spring, and this will make it easier or harder for the drainage of the excess water. And at the bottom here is where the inlet connection is. So this tube is actually sticking inside of the water tank, and the tube has a thermal jacket or casing around it. And if you look at the picture at the bottom, you'll see that there's actually a metal rod inside of there with a spring. So when the temperature gets around 210 degrees, like mentioned in the previous slide, the pressure and the water buildup will come from the bottom and actually push up this metal rod, which will in turn push up this spring and allow any excess water to drain through this drain connection, which will actually have a tube connected to it, and that's where the excess water will go in cases of high pressure and high temperature. Like mentioned in the previous slide, whenever the TMP valve releases excess water, it is actually discharged through a discharge tube, which is usually on the side of the water heater, and it is discharged either onto the ground or into a drain or a discharge pan. These tubes must be able to withstand above 250 degrees Fahrenheit because, like mentioned in the previous slide, the TMP valves are designed to start discharging water at temperatures of 210 degrees and above. So usually you don't want to make these discharge tubes out of anything like PVC or plastic pipes. The main three materials usually used for discharge tubes are copper, PX, and CPVC pipes. It's also not advised to use iron pipes due to potential rusting. You want to use materials that have better corrosive properties than iron. And also, one last thing to mention is discharge tubes and drainage should be inside in cold climates so that freezing doesn't occur. Next on the safety device list, we have the thermal expansion tanks. These weren't really required till recently, so not every water heater has these. Some of them might just have a check valve instead. But um, the main function of this thermal expansion tank is to absorb excess water and pressure when the cold water is heated up. So what happens when you start heating your cold water up in the water heater is the water expands around 2% from when you raise the temperature from 50 to 120 degrees Fahrenheit. And this can cause a lot of issues and a lot of plumbing issues and potentially a line burst, so which will cost you a lot of money. So the main thing about the thermal expansion tank is that it could potentially save you a lot of money. And the way it works, you see this picture up here to the right. So you connect this thermal expansion tank to your cold water line and your main water line, I guess you can call it. And while it's in use, only half of the thermal expansion tank is filled with water. The other half you see is filled with compressed air, and there's a rubber diaphragm in the middle. So as your water expands from heating it up, this water or this will push water in the tank and then compress the air so that this water buildup is not in your actual pipes. So the past three safety devices have been for both electric and gas-powered water heaters. So now we're going into part of the presentation where these safety devices are only used for gas-powered water heaters, and the first one being the draft hood. And so pretty much what it is, it allows excess combustion gases to leave the tank, and these gases, or this draft hood is actually connected to a ventilation pipe, which when there's excess combustion gases, it will leave through the draft hood, through the ventilation pipe, and into the atmosphere. So next up in the safety devices, we have the gas train thermocouple. This is a safety device that's used in gas-powered water heaters. In these water heaters, you have a setup similar to what you see in the bottom left picture. So you're going to have a pilot flame that is used to light the main burner. And while this pilot flame is lit, it will induce the thermocouple to give out a voltage of 30 millivolts. This voltage will be sent to the thermal cutoff switch, and the thermal cutoff switch will not be induced to shut off the gas valve while there's a voltage being applied by the thermocouple. But as soon as that pilot flame goes out, the thermal cutoff switch will lose that connection to the thermocouple and it will actually shut the gas valve. This will allow no more excessive combustion from that gas supply, and therefore saving you from an explosion or another issue like that. Here's the last device we'll be talking about in this presentation, and this is called the thermal cutoff switch, or also known as the TCO switch. This was shown in the last PowerPoint. It was connected to the gas train thermocouple, and this TCO is the actual device that cut off the gas valve. A little bit about these devices. I mean, they're pretty inexpensive, and they're used primarily on gas-powered water heaters, and usually just the newer gas-powered water heaters. And also, once this TCO actually cuts off the gas valve, it has to be reset manually. And usually when this happens, the cause is because excess combustion occurs due to vents being blocked either on the top or the bottom of the water heater. And yeah, that's pretty much it. Thank y'all for listening, and our references will be on the next page.